Hey, what is up guys? My name is Cherno and welcome to episode 15 of the Serialization series. So today we're going to attempt to finish this series, so to speak. So last time we of course implemented the deserialize function for the object, right? So if I go to RC object, we implemented this deserialize method. Everything was pretty much complete there except for the actual other deserializations that we had to do, which were fields, strings, and arrays. Now they're all pretty simple to deserialize really, so I'm going to go ahead and try and finish that up today so that we can basically be done. And the next episode, if I do have a next episode, which I probably will, I'm just going to kind of use that as a closer and maybe give you guys some other things that you could do to optimize the current library that we have here. Although I think we're going to pretty much wrap this up. So let's take a look at what we have to deserialize. We've got fields, we've got strings, and we've got arrays. Let's begin with fields because they're the first thing we have. The best way to look at how you deserialize something is actually looking at the way that you serialize it, right? When you're designing a format, the first step, as we did as well, is actually writing the format. When you're reading the format, all you really have to look at is the way that you wrote it and pretty much just reverse this. So instead of writing bytes, we should be reading bytes. So if we come over here, I'm going to go down to the very bottom. I'm going to type in public static RC field deserialize. We're going to have our byte stream called data and a pointer. We're going to, again, read in the first byte, which is, in fact, I'm just going to copy this right now. Okay, cool. So first thing we're going to do is read in the container type. So we'll do int or byte container type equals data at pointer plus plus, right? I'm going to set to make sure that our container type is in fact the container type. All right. Okay, cool. The next step is the name length and the name. So this is again going to be identical to the way that we did it here. So I'm going to pretty much copy that. We're going to make our RC field, which is our result. And just set it equal to a new RC field. We've got a private constructor, perfect. We'll set result.name length and result.name here to exactly what we need. The next step is the type. Okay, this is where it gets interesting because there are two things we have to consider here. First of all, getting the type is going to be easy, right? The type is just a single byte. So all we really need to do is say byte type, I guess, or result.type, in fact, just equals data at pointer plus plus, right? We got the type. And now we need to think about the actual data because we could of course just say result.data or whatever it was. I think pointer equals read bytes or something, read byte. That just reads a single byte, right? How do we read a byte array though? Do we not have that? We might not have that. I guess not. I guess we don't. Okay. Sure. So read bytes. We'll do read bytes. We've got source pointer length. And then all this will do is basically, or rather source pointer length. Let's do something like this instead. Let's do source pointer and then the destination. Okay. And then we'll use that destination length to get where we want to go. So we'll set I equal to pointer. We'll say I is less than pointer plus destination.length I plus plus, and then we'll just go ahead and copy those bytes. So we'll say destination. Destination is probably going to be, let's rewrite this a little bit. We'll say 0. We'll say length I plus plus. Then we'll say destination I is going to equal source pointer plus I. Okay, and then that'll just nicely copy that data and give us a. I'm not sure if we really. I think when we read things, we generally tend to return them anyway. So I guess in this case, we can return pointer if we really wanted to. I think we'll just return void though. Okay, cool. So there we have it. We can read an arbitrary source of bytes here based on the length that we provide. So we know that the type tells us what the size is because we can query that by going to type.getSize. So we can just check the size. So we can say byte or result.data rather equals new byte type.getSize result.type. And then we can just say read byte from data at pointer with result.data is where we're reading into, okay? Or read bytes rather. And then that's it. We can return our result, which is pretty cool. So that of course returns void. Okay, cool. And then if we really wanted to, of course, we can say pointer plus equals, let's see, pointer plus equals this, right? Now, the other problem that we have here is we don't really know what the size is. I mean, like for us to read the size, we need to make sure that we have data.length, and I guess we do know the size actually when I come to think about this, because there's no kind of update that we have to run the same way that we did in field or object. Or in fact, this is field. But the way that we had to update the object size or anything, it just knows because, of course, the only two dynamic things it has are the length of the data and the length of the name, both of which we set here. So everything should be good as far as that goes. Cool. So do we have a way to get the name of the field? No, we don't. So let's go back into RC object. We'll still get name. All right, here we go. And in fact, I guess we'll move that up a bit. Okay, cool. So we can get the name now. And then I guess we can get the size as well if we really want to. So everything kind of checks out there. Cool. Let's go on to arrays. And I'm just going to go to RC field and I'm going to just copy that. I'm going to bring that with me into RC array so we can make an RC array deserialize. Okay, so how is this going to be different? Well, the container type is still going to be the same. The name length is going to be next. Again, this is kind of important. So I think I'm going to go ahead and steal everything we have in get bytes just for reference. And we can kind of, I'll just put it at the end here. This is now going to be an RC array. Okay. Good, we got a private constructor. So we got the name, then we got the size, type, count. So we can kind of start referring that to our little cheat sheet that we have here. So name's good. The next is the size, okay, and then the type. So we can keep our type deserialization, which is what this is, or rather, should I say this, right? But before that, we actually do need to read an int. So we'll say result dot size equals read int, and then this will be byte source, which is data and the pointer. Then we'll do pointer plus equals 4. Then we'll read in the type. So we've got the size, we've got the type. Now the count, which is an int as well. So we'll just steal that. We'll read in the count. Cool. And then finally, we actually have to read in either data, whatever. We've got a bunch of different things that we have to read in depending on what they are. Now, this is where this gets a bit tricky because what we've got is a stream of bytes. However, what we really want to do is read it in as a stream of either like short data, char data, int data, long data, float, whatever, right? So we need some way to convert our bytes into an actual array that we want to read, okay? And we're just going to use the existing functions we have in our serialization writer class to accomplish that. So first of all, let's take a look at this. We've got our type switching here. We've read everything we need. The last thing that we read here, as you can see, well, this is actually part of the old code. Let's kind of delete this for now. Whoops. Okay, so we've read in count, and that's the last one. Now all we need to do is read in data. Now we know how long the data is because of the count. Okay, so that's also important. So first thing we'll do is we'll switch based on the type. So we'll do result.type. Okay, And then instead of writing bytes, we're going to be reading them, obviously. So in this case, we're going to do read bytes. Now we already have done that, as in data pointer, and then the result of where we want to store it is important. So for example, if it is a byte, we can just say result.data equals new byte. Now how do we know how many? Result.count, of course, is the amount that we have here. Yes, okay, so and then we can just say that we're reading from data into result.data, and of course that's the amount of bytes that we expect to read. Now the next step is going to be kind of similar, okay? It's just that instead of creating a data, we're going to be creating a short data, right? Which is going to be an array of shorts, result.count as well. And then we're going to be feeding that in here. Now, we'll have to make a function for this. So we'll say public static void read shorts, okay? So this will be a short array. The short destination here is what we're going to use. Now, this is where this gets a bit tricky. What we want to do is we actually want to use our existing read short to read in each element. So all we really need to do is say destination I equals read short from source I plus pointer, okay? Or rather, we don't even have to use I plus pointer because we actually pass in source and then pointer. All right, and then the other thing that's important is that that returns a short, okay? So we know that our pointer has to be plus equals 2 every single element, because of course a short is 2 bytes. So we'll just say get size. What is it? Type. What even are the types that we made? Oh, byte is type. Okay, so wasn't it type dot? Yeah, type dot short. That's what I want. Okay, cool. So that way we should be able to read all the shorts. Now we'll have to duplicate this, of course, for everything. So read shorts, read ints. What else do we have? Chars. So I think I'll just move this down here. Chars. Longs, floats, doubles, and booleans. So longs, floats, doubles, and booleans. Longs, floats, doubles, and booleans. Cool. So read ints, of course, is going to do read int, and then take in an int array, and then this will be type int or integer. Then we'll have longs. So did I skip chars? I did skip chars. So char, read char. Okay, that looks pretty good. Long, read long. All right, looking pretty good. Then we have floats and doubles. So this will be float. This will be read float. This will be read double, double, and boolean. Okay, there we go. So that should be pretty good. We should be able to read all of the bytes that we have there, and I think short char integer. I'm just checking everything. I think that is all correct. Cool. So there we go. Back in RC array now, we of course replace read bytes with read shorts, and we have the short data and everything works out well. So let's do that for all of these. Okay, so char data equals new char array, and of course char data is what we take in here, and we are reading chars. Okay, integer. So there's a lot of stuff here, unfortunately, we have to replace. Int data, read ints, long, read longs, float, floats, double. So many data types. So many data types. What have I done? Double, and then finally boolean. Okay, so that looks pretty good to me. I think we're good. So that should read everything. And then of course, if we want to advance the pointer, which we don't really have to do, but we can, it will just be pointer plus equals result.count times, we could advance the pointer for each of these, but it's fine. I'll just do result.count times type.getSize result.type. There we go. And I think that's it, right? Yep, that's definitely it. So we should be able to deserialize arrays now, and that should all be perfect. So let's move on to our final challenge, which is a string. So how do we deserialize a string? Well, glad you asked. Let's go back to field and steal that definition. It's a bit shorter than the one that we have in array. So let's return an RC string. Again, we'll just make sure that container type checks out. Then we'll create an RC string. Good, we've got a private constructor. So let's look at this. Really, we just have the name, and then we have the size, count, and characters. Okay, sure. So result.name, that's all good. Result.size is going to be read int data pointer. Result, or rather pointer plus equals 4. So that's the one that's straight after name. Then we got count, which is another int. Good. And then finally, we've got the actual data, which is an array of characters. So now that we've made that situation up, we can easily make that work. So we can just say that result dot data, I believe, right? No, it's called characters. Result.characters is a new char array. It's going to be result.count. Then we'll read that in. So we'll say read chars, data pointer, and result.characters. Again, if we really want to advance that pointer, it would be pointer plus equals type.getSize type.char, which is 2 bytes, and of course result.count times that. And then finally, we just need to convert that into a string so that we can get the string. Now that this doesn't have a get string, unfortunately. So let's make that. So first of all, we'll have to get a get name going. You'll also note that, by the way, we are outputting a string as a char rather than a byte, okay? And we're just allowing, basically chars, of course, are 2 bytes, so we are kind of allowing our strings to be like Unicode rather than just 1 byte ASCII. So of course, in this case, we're allowing 2 byte characters, right? Something like UTF-16. That's our maximum. We're not supporting UTF-32 or anything like that, but this should be enough for pretty much everything. Cool. So that's just a little thing that I felt I should mention, because you can see that names are 1 byte characters, whereas these are 2 byte characters. So that's a bit different as well. Okay, so we'll get name. Now I'm hoping, I actually don't know this. I'm hoping that we'll put in get name first of all, but also I'm hoping that get string, that there's actually something in string that takes in the character thing. So if we have, let's see, we've got char value. Allocates a new string so that it represents a sequence of characters currently contained in the. Okay, fantastic. So we can actually do that, really easy. So we'll just say characters, and we're done. And that actually should be it. Okay, that should work perfectly, I'm hoping. So if we go back to our RC object, now that we've got all these 3 figured out, let's get rid of that for now. We can say something like result dot field count. So these are of course our fields, pointer plus equals 2, deserialize fields here. So we'll now go through and iterate through these field counts, okay? And again, this is going to be something that is identical to the way that we did it here in database, where we actually went through the object count and we deserialized the object and then advanced the pointer and then added that, it's going to be exactly the same thing, right? So if we go back to RC object, we're going to create a new RC field. So our field in this case will be RC field dot deserialize data pointer, right? I'm going to go ahead and say fields or result.fields.add field and pointer plus equals field.getSize. Copy that, do the same thing for strings. So this will be string count, RC string deserialize strings.add string and pointer equals string.getSize. Okay, and then finally the same for arrays. So array count, RC array, just grab that, arrays.add array, and there we have it. Okay, cool. So if I made no mistakes here, which is actually unlikely, this should pretty much work. And it should give us our RC object. So again, I have no idea what's going to happen. I mean, it should work though, because we know that we have iterated through the entire file in terms of objects. So unless we made a mistake with the size somewhere, which again is just very possible, everything should be okay. So that being said, let's, I guess we can test this out now. So let's see what happens. So first of all, let's say that this still works, right? And looks like we crashed. With a string index out of bounds, again, it's a string index out of bounds. So this has got to be, so an RC field deserialization did not work. So let's go back to here and see, this is the first field. Interesting. Because the fields should be straight after, okay, cool. So that is interesting. The first field failed, really? So pointer is 200,000, okay, sure, because we're deserializing that massive array. Wait, I've just got a little thing I want to check. Yeah, okay, that's fine. That's wrong though, because why is the point, fields are stored before arrays. Wait, hang on a minute. That's the reason. This is if we want to early out. That's why we should not be advancing the pointer by that much. There we go. So we still work. Yeah, that was, I was going to say, the reason I worked that out as, again, so quickly was because that pointer was at like 200,000, which is because we've got this massive array here. But remember, even though we do add the array first, arrays are actually written out last. So there's no way the pointer would have iterated through the array before fields, since fields are first. So that was a close call there. Okay, so we should have everything now. Yeah. So if we go back to main, I'm not going to bother printing out everything. That'll take forever. I am just going to kind of put a breakpoint like right here. I don't know if I can do that. Doesn't look like it. That's why I was going to write something. So if I put a breakpoint right here, we should just be able to look through the structure. Okay. So if we go to debug, and hopefully this all checks out. Let's take a look at what we expect first of all. So we expect, looks like an array of random numbers. We expect an integer to be set to 8, x position, y position, 2 shorts, 2 and 43. Another object called entity, which just has a string that says hello world, which we'll really only be able to see if we do get string. And then we've got this RC string create as well. So we've got a string that is another example string. Oh, we've got a character array versus an actual string that we have. And then we've just got two objects. One of them has a boolean set to false, whatever. So let's take a look. This database of ours has a size of 200,306. Okay. I expect that to be correct. We've got a name, whatever. We know the name checks out. So let's take a look at objects. First of all, how many objects do we have? 5 objects. So that's, I'm guessing, correct. Let's see. So database. 1, 2, 3, 4, 5. Okay, 5 objects. Makes sense. Each of these objects, the first object should be this big one. So it should be called entity. Again, I don't know if it is called entity. It's got three fields, good. It's got two arrays, also good. One string, I'm hoping for. Yep, one string. The name is that. The fields that it has, 10 fields. Really? 10 fields. No, it doesn't have 10 fields. It's got 3 fields. Why is that? Oh, I guess that might be the size of the actual list. That's fine. I didn't know that Java showed you that. We've got the data, 8. There's our integer. Anyway, you can see that we can kind of look through this, and I'm assuming that this data is correct. It's hard to tell. I mean, that 8 looked like it was right. What else do we have? Exposition. So we should also see 2 and 43. So if we look at the data, 2, good as a short, clearly. Then the other one should be 43, which is going to look a bit different. Okay, no, it's actually just going to look like 43. I forgot this display wasn't in hex. So there we go. That looks pretty good to me. Let's look at something else. So we should be, the third object should have this boolean set to false. So if we go to the third object, which is this one. No, this one. No, hang on. This is the last object. No, it's the second last object. So it's object number 4. Then the okay, well the size is 26, sure. And then it should just have one boolean. So field count is 1 field, size is 1, perfect. And it's got one field, and then the field is type 8, which I'm guessing is boolean, and the data is just false, okay? Fantastic. So there we have it. You can see that we've actually now, we have the ability to deserialize. That actually worked for the first time, so I'm actually really happy. We've got the ability now to deserialize all of this stuff that we have here. Let's quickly also loop through our other things, just for peace of mind, just so I can output them. So we'll loop through our fields, right? And we'll just print the names, right? So fields less than database dot fields dot oh, sorry. We have to. So we're looping through our objects, and then the these are the objects. Okay, sure. So objects.fields, objects.getI.fields, which is private. Why is everything private? This is so annoying. There's no point in making this stuff private, by the way, because we're clearly going to be accessing it immediately. So like certain things shouldn't be accessed, like the string count. There's no reason, but this stuff definitely should be. Okay, especially because remember, if we do make a getter for fields, we can still modify fields. It's even if we make a getter and no setter, we can't change this part of the field, but we can change the contents of fields. So as far as I see it, public is totally fine. Okay, back in main. So fields.size I++. Wow, that's a big statement. We'll say system.println database. You know what? It's just going to get really messy if I keep doing this. So I'm just going to say I'm going to convert these into for each loops. RC object in for each of those in database.objects. Then we'll make an object. So RC object. Oh, we don't need to. Of course, that's the whole point. So that's easily done. Oops. Okay, now we go through the object's fields. So RC field in object.fields. And we'll print out a field.getName. So we'll indent that even more. And then, yeah, we'll do the same thing for string. So in this case, I think we'll just print out. We could print out the name. Yeah, we'll do that. That's fine. We'll probably make a bit of a break here. Okay, cool. So we got the strings now. String.getName, and then finally array. This is again just making sure that everything works. Do arrays not have names? I guess I just don't have a getter. Yep. RC field, get name. This really is begging me to just refactor it so that we're not duplicating as much code as we are, but it is what it is. Okay, there we go. So let's run this and see what happens. Wow, a lot of stuff here. Okay, so it looks like entity has 3 fields, integer, x position, and y position, 1 string called example string, and 2 arrays, one of which is random numbers, the other one is string. Cherno has no fields, nothing. Cherno 1 has nothing. Cherno 2 has a single boolean, a single field called a, which is the boolean, and then Cherno 3 has nothing. So there we go, okay? Everything looks to be in order. We've successfully deserialized our data, and we can even loop through it, which is pretty awesome. In fact, let's just quickly also see what the string is. So I'll do string.getString, just out of curiosity. And then you can see our example string is testing our RC string class. So how awesome is that? We've got a serialization format, which is pretty easy to use. Next time, which is the final episode, so 16 is going to be our final episode, we're going to actually explore how we can use this. And we'll probably extend the API a bit, and we'll talk about how we can actually use this in an actual kind of game scenario. Because all of this is like in our little sandbox test thing. You know, if I had an actual entity class that I wanted to deserialize and serialize, or if I had an actual game state, how can I use this serialization format for that? Okay, so we're going to look at some real world scenarios next time and actually see this in action. And I'm sure that along the way in that next video, we'll also be able to extend the API of our serialization library, because we'll see that maybe some things could be a lot easier. So anyway, thanks for watching. If you enjoyed the video, please hit the like button, and I'll see you guys next time. Goodbye.